Welcome to this micro course, providing you with best practice skills and know-how. This session is given to you by the Van Haren Group, your partner to enable best practice learning. With your host, Maurits van der Plas.
Hello, welcome everybody to this micro course, Conceptual Modeling versus Logical Modeling. I'm here with Patrick Derde, Chair of the Bioinformation Architecture Working Group. Thank you, Patrick, for joining us again in this second micro course. As last time, Patrick has a lot to say. We have quite some content to share, so we'll save the questions till the end of the session. Please do leave them in the chat so we can bring them up. And I would say directly again, Patrick, take it away. And we're all very curious, I'm sure.
Okay, thank you very much, Maurits, and everyone. A warm welcome to this micro course. I'm going to approach this topic of conceptual logical modeling from a Bion perspective. For the people who don't know me, my name is Patrick Derde. I'm from Belgium, and when you look carefully in the right top corner, you will see what the weather will look like in this weekend. So have a nice look at it. I'm going to talk about some theoretical things, contextual, conceptual, logical, physical. What is it according to ISO? But also how are we in Bion, the banking industry architecture network, how are we using it in doing our information architecture modeling work? I will show this into for the conceptual part. And then I will give some guidance on or thoughts actually on how to transform your conceptual models into logical models, and then we are ready for some questions. So let's start with contextual, the theoretical part, contextual, conceptual, logical, and physical, and we are focusing on what is ISO telling us about these terms, these concepts, and then it is especially defined in the ISO 11179 and the 42010. The 42010 standard, for the people who are familiar with TOGAF, that's actually the standard that TOGAF is using to describe its enterprise architecture framework. So let's have a look at it. And then we say contextual. What is contextual? Contextual, according to ISO, is giving your concepts in a broader context. It's high level. It is giving an idea. It's giving an idea of the ecosystem. It's telling the why we are doing this modeling. And why we are doing this modeling is actually completely based on what are the stakeholders, what are their concerns, what are their goals, what are their high-level requirements, and then we will show that in a nice, understandable picture, very informal. Talking about conceptual, that's something else. Talking about conceptual, there the purpose is to give a high-level overview of what are the most important things, the most important components that we are talking about, and how these are related to each other. So it's high level, which means we leave out the details. It's abstract, so not necessarily details we're not going to show. We'll only stick to the fundamental components, and in this case to the fundamental data objects and how these are related to each other. Also for this, there is a quite common understanding that we say, well, when we are talking conceptual, we are creating entity relationship diagrams, but we are not bothering about the attributes. Okay, it can look like this, but what we also see that is conceptual models which are presented like this well, when we look at this, this looks more to a kind of contextual models. So confusion is created. Other people are saying, well, when talking about conceptual models, we're talking about diagrams. But yeah, a model is not a diagram, as we all know as enterprise architects. So we're not very happy with that neither. Then we come to move to the point of logical. From the perspective of logical, then we see that there is more common understanding. And then we say logical, that's actually structuring the components in such a way that is fit for the purpose of using in digitalized environments. So the data structures are not really the data structures as they appear in the reality, but it will be the data structure as this will appear in automated information system. In that case, we talk about the logical data models with their data types and their relationships and so on. It looks a little bit like this. Some boxes, entities with attributes and some relationships between them. Of course, the big challenge is to find out what will we put into the boxes and what makes a box a box. Then we move on to the physical part. In the physical part, we are saying, okay, we have our logical modeling, completely platform and technology independent. Now let's add some technological or platform specific aspects on it. And then we are thinking about, we are going to define, to realize actually our logical data models into a physical data model, which means we are going to realize the logical data models into an Oracle or a SQL Server or whatever. So it looks more technical because our data types will be specified in a technical in a physical data type. Our names of the boxes, they will become really table names, and the columns will become and the attributes will become column names. So also not a lot of discussion about this. So summarized: contextual, conceptual, logical, physical. Contextual, give the ecosystem of the concept you're talking about. Conceptual, abstract but exact representation of what is going on in reality. Logical, we have restructured the things to be fit for purpose of automated system. And the physical part is we're adding the technical aspects on the data models so that we can create our real database tables. I was talking about the fact that some people are saying that that conceptual models are diagrams. Well, when we know Archimate and when we know TOGAF, then we know that the diagrams are only a representation, and that a model is actually a set of concepts, and these concepts are elements and relationships, and then connectors between the relationships. And that is also how Bion will use this elements, this concept of a model. And we are aware that we are going to create multiple diagrams. Let's say we are going to create multiple views based on the model elements. So we in Bion, we will be very strict on it, and we will make that distinction between the model elements, which are actually the entities, the attributes, and so on, and how these are related to each other. And the need for the right data is fully derived from the need that the stakeholders have defined. And here we see on this diagram, we see that in our models, we are creating model elements with a relationship in between, and we are going to visualize it by means of diagrams, catalogs, and matrices. So, but then there is also that part of architecture, because Archimate and TOGAF is talking about architecture. And when we look at the definition of architecture, the definition is saying architecture is the architecture of a system. It's the fundamental organization of that system embodied in its components. the relationships between the components and the environment, and the principles governing its design and evolution. So when reading this definition, there is clearly a distinction between architecture and design, which means that we also have to take into account what is architecture, what is design. And this can be shown by means of looking at a company. When we are looking at a company, we typically have the strategic level, we have the tactical level and the operational level. And at the strategic level, we are going to define our conceptual models, which are representing the fundamental components and how these are related to each other. Let's say the enterprise data model is created here, and then there are guiding principles to design. These guiding principles to design bring us to the system design, where we typically make use of languages UML, BPMN, ERDs, and then we are going to deploy these things into reality, and everything is actually guided. The implementation is guided top-down. When changes are needed, that's done bottom up, and we have our architecture change management. So we also have these three layers of strategic, tactical, operational, or let's say architecture, design, and operations, which means that we are fully conformant also with what is stated in the DAMA DM book. In the DAMA DM book, they are saying, hey, we are talking about data architecture, data modeling and design, which means data design, and then the data storage and the data operations. So when we combine this contextual, conceptual, logical, physical, and architecture, design, and operations, we come up with a diagram with a matrix which is summarizing the expected models. Contextual, mostly very informal. Architecture, abstract. Design, detailed. Conceptual is very formal, abstract, using languages such as Archimate, UML, and so on. Design, conceptual design, detailed. From a logical perspective, we remember that logical means actually we're going to restructure from the perspective of automated systems. So also very formal, abstract, exact, and then often we call this logical architecture. Sometimes we also call this high-level design, but very formal, exact, using the same notations as in UML, ERD, BPMNs, and so on. And then physical. Then when we're talking about physical, that's only, in my opinion, only at the design level, where we're going to add the technical aspects of the DBMSs, and then we can create the scripts, the DDLs, to generate our tables or to change the tables and the columns and so on. And then when we are talking about the physical aspects in operations, then we are really talking about our deployed data stores and message handling systems. So when we now apply this matrix to the BION, then we see that in BION we will only talk about the conceptual part. Conceptual at the architecture layer, conceptual at the design layer. But you see in the column logical, you see work in progress. It means indeed that at the moment within the BION organization, we are trying to find out how can we come with a more logical approach of this conceptual modeling things. From the design perspective at the logical, then we have already defined our what we call the semantic APIs, which means actually these are focused from a data perspective on the input-output parameters of the semantic endpoints. From a physical perspective, well, we only presented it in a REST format or in Swagger files and so on. This is something that you can call physical. Now, let's apply this. How this BION applying this? let's have a look. Bayern is making use of patterns. And one of the patterns is the distinction between the term that we are using and the concept that is defined, that is represented by the term. So what is important in modeling, that is that we identify the concepts, we have a clear definition, and then we can give it multiple terms that can be presented in a glossary. So that's one thing. A second thing is that these concepts we are talking about, what are these concepts? And then Bayern is saying, you know what, actually world is simple. We are talking about parties who are situated at some locations. They are doing things that are events, and they are doing it at some point in time. They are offering products to customers, to parties, and by offering these products, selling these products, they come up with agreements, which are terms and conditions. And then when in these terms and conditions there is promised something, then you can imagine that you have instructions, such as an invoice, and then you will pay that invoice, that's in the transaction. You use different channels for that, and when these transactions have financial consequences, then we will enter this on the accounts, and everything will be very often made perceivable on documents. So this is, in a nutshell, the type of business object that Bayern is talking about, and these business objects are related to each other according to a standard pattern. And everything what Bayern is doing is creating variations on this standard pattern. Now that's we call that a content pattern. But now each time when you have identified an object, for example, or whatever concept, then you can say, okay, now I want to model this concept. And then we use a structure pattern, which means that you can say, okay, we have an object. How is this object described? And then we identify multiple descriptors, multiple identifiers, multiple attributes, multiple life cycle states. And then these objects are related to other objects. Objects of the same type or objects of a different type. That's the business object relationship. But you see on this diagram that we did make a distinction between the yellow and the green boxes. The yellow boxes are the instances. The green boxes are actually the classifications. And within Bayern, we're saying an instance is not a classification. So the characteristics of the instance must be distinguished from the characteristics of the classifications. And the importance of it will be shown later on, which means actually that when we are talking about these business concepts, that we have different types of business concepts. Also for that, we use a classification pattern. Some of the concepts are real business objects. Other concepts are business information, which means actually that is data of different business objects which are brought together in something, in a meaningful message. That's business information or classifications and so on. So we also use a pattern to help us classifying these concepts. And now I will show you why it is important, these classifications. What I'm talking now is conceptual, purely conceptual. We make a distinction between taxonomical classifications and functional classifications. Taxonomical classifications are these types of classifications that we can say in whatever other class I put the things, the characteristics are always the same. They are actually classifications by nature. Functional classifications are more classifications by interest. And let's give it an example. When we have the animals, then we see that the animals are classified according to a taxonomical classification. Let's have a look. We have here some animals. A dog is always a dog, will never be a goat. A dog is always a dog, will never be a chicken, and so on. So this is clear, that's a taxonomical classification. We can subclassify this taxonomically. And we can talk about the mammals, the birds, and the fishes. That's a taxonomical classification. During the whole life cycle, a dog will remain a dog and distinguished from a goat. the characteristics will always be the same. But when we classify now from the perspective of a functional classification, food and non-food, for example, the characteristics of the dog are the characteristics of the dog. The characteristics of the fish are the characteristics of the fish. But what happens if we all of a sudden we say that also the fish is sometimes non-food? Does the fish have other characteristics? Of course not. It is the same characteristics. Result is that if we model this as two different types of entities, then we have created data redundancies. So we are going to avoid that. So by thinking like this, we have a methodology for modeling, for conceptual modeling, where we're saying we're talking about something, we try to find out what we are talking about. Is it the business object? Then we're going to try to find out what type of business object is it. And then when we did find out what type of business object it is, how is this object described and how it is related to other elements. And then it turns around, and so we come to a clear definition of what we are talking about. Now I want to show you this in the repository of Bion, and for that reason I'm going to the Biz Design repository, and I'm going to show you the information architecture overview point. I'll make it a little bit bigger. And then we see that we have this, this concept classification pattern. That's what we have been talking about. We look at the content pattern. These are the basic objects and how these are fundamentally related to each other. And we look at the structure pattern. So this is all identified. Now let's have a look. How does it look from an account, for example? Then when we take the account, then we see that the account here, maybe a little bit bigger, that the account here is the core business object, and that this account is related to other accounts. So you see here in blue, we have represented the account relationship, but we also have a relationship with another object type, party, for example. Then you see the account involvement. And in green, we can see all the different types of classifications that we have. This is what we call a diagram, which is visualizing the conceptual model at an architecture level. Now, when we want to see it at a design level, then we go into more detail, and let's have a look here. And then you see that it is fully filled with the details of the attributes. So you see here the account and the account involvement with the parties and so on, and with the logical data, with the conceptual data types that we see here. So this is how Bion is doing these things. Now, when we have seen this conceptual based on the account, let's have a look what it means when we have to translate this conceptual to logical. When we translate conceptual to logical, it means actually that we're going to say, now we are going to restructure this from the perspective of we're going to create digitalized systems. We're creating logical data models. And then, of course, this is really an art, and this is based on, you cannot give a general rule on this, but based on the requirements, we are going to formulate some translation mechanisms. And the translation mechanisms are all based on the fact that we have objects with relationships and characteristics of these objects and classifications. So what will become what? Maybe you did hear that I'm always talking about objects and classification, and I did not talk about entities. Now, typically, when talking about the logical things, we're going to talk about entities, which means that very often objects, no, nearly always, objects will become entities. Why? We are going to merge objects of different types. For example, we have the object party, we have an object customer relationship. Very often it is merged into a customer entity. Or we have an object party and we have an employment agreement. Very often this is merged into an entity called employee. Or we have an agreement of a certain type and we have the object of account. Well, we will call that an agreement account. Let's say we have a current account agreement and we have an account. Well, we will have the entity current account, or a savings account agreement plus an account, a savings account agreement, a loan account agreement, and so on. So this very often we are going to merge atomic business object types into something aggregated. Merge of business object result in entities. Sometimes we split business object types. For example, the party object. Sometimes the party object is split into based on the life cycle of the party. A prospect, a customer, or an agreement, which is when we are negotiating the agreement, it's an offer. And soon as we have agreed on the agreement, it becomes a contract. Well, you can decide from a logical perspective that you're going to create two entities. So objects become entities. But also, what we see very often is that functional classifications become entities. We have an entity, customer, supplier, broker, etc. Or we have products which are offered to different market segments, and then we're talking about current accounts and corporate current accounts, or consumer loan and corporate consumer loans. Now, let's have a look what this means from a conceptual to logical perspective when we apply this on account balance. When we apply it to account balance, we see that we have the object account, and the account has a number of characteristics. What is a characteristic of account? That's the account balance. What is the data type of account balance? That is account balance. Now, twice the same name. Let's have a look. The data type, when talking about an account balance, we see that it is a balance amount, a calculation date, and so on. So which means actually that the data type is made up of multiple attributes. These multiple attributes, one of these attributes is the balance type, which is indeed, again, a classification, balance type values. So let's take this example to move on and to say, well, sometimes attributes can become entities. And this is typically the case when we apply the normalization, multi-attribute values, they become entities, or where there is a need for historical data, they can become entities, or the account balance will become an account balance entity because of the fact that we have multiple types of account balances. But it's also possible that we translate the multi-attribute values. The multi-attribute value, you see that here, when we have this 0 ... star, that's an indication of a multi-valued attribute. It's possible that we decide that it will become simply a number of attributes, of named attributes, such as an opening balance or the free balance. And then the opening balance as well as the free balance are then of a more atomic data type, which is amount. The relationships, they can also translate into entities. Many-to-many relationships, very often translated into entities. But also many-to-many relationships can be translated into attributes, which means when looking at agreements, accounts, locations, etc., always a lot of involved parties are involved. So they can result in attributes with role, which we call the party role attributes. So Data types also. Data types can be translated into attributes, but can also be translated into relations, and so on. So transforming, moving your conceptual data models into the logical data models is really based on what are the logical data requirements as specified by your stakeholders and as needed by your information system. We're going to take into account performance, accessibility, availability requirements, and so on. And this can result in a specific logical structure. So this is in a very short time the overview of how to move from conceptual to logical data models. I'm not going to talk about how to translate this then into physical models, because then we are going to add the DB2 or the Oracle or the SQL Server specific aspects on these models. So I think we can make some time for questions.
Yeah, thank you very much, Patrick. Very elaborated story, and you went through it quite fast, I think, right? You very comprised information, but you did manage to cover it all. If somebody has a question, please do let us know. So far, there were no questions. I think also because we mentioned in advance that they can save the questions till the end. We did already pass the time, so if people are already closing up, no problem. To let us know if there is a question. And I think that if not, then well, that was a very elaborated story. What will be a next step from beyond here, Patrick? Because we mentioned conceptual models versus logical modeling. What will be a logical follow-up subject? You think?
That's an. I was not expecting this question, Maurits. So I think what people need to do is to try applying this way of working, because when you're not applying this way of working in this very strict way that Bayern is doing it, there will remain a lot of discussion. What is a concept? What is an entity? What is an attribute, etc. And you can discuss this, and everybody will have some. They will be right from a certain perspective, but what is important is that we always focus on the things that exist in reality, and then we start combining them into entities or tables. So, but from now on, just apply it, try it, move away from. And the first step, move away from the data types that you're familiar with. The data types are these very logical, technical data types, whilst Bayern has defined more the conceptual data types. For example, that account balance. That account balance is not only an amount, it's also a whole set of attributes that makes up that account balance. The same is for an identifier. An identifier is not only a number. No, it's a set of attributes that is making an identifier an identifier. Amongst the issuing authority is such a characteristic. The data type is such a the format is such a characteristic, the starting date and ending date of identifiers, and so on. So conceptually we think broader than what is finally used in the software.
Yeah. Okay. Thank you. So we got 2 questions so far. If somebody else has a question, please do let us know. We're already past the time, but we'll continue with the questions. So we got this question here. If you can see, Patrick.
Yeah.
We are creating a logical model for DWH. how important is it to do this based on the organizational GMC? And
Yeah.
what if you don't do this? Could you maybe first elaborate the question, Patrick?
Yeah, so if I'm understand, so you're going to create a data warehouse, which means actually that you need a kind of a structure of what will be in my data warehouse. So that is the different other people are, some people are calling this an enterprise data model that needs to be created. So you, in my opinion, you need to create first your conceptual data model, and then you can derive from that. You can start defining your logical data warehouse model. And your logical data warehouse model is then you're going based on the purpose of your data warehouse. Is the purpose to create reports, then very probably you will make use of dimensional modeling in your logical model. If it is more the purpose of actually I want to query my repository in a way that I don't know yet, then very probably you will make use of the graph modeling, or you will make use of the entity relationship modeling. So, in my opinion, to keep grip on your enterprise, your data warehouse model, it is, in my opinion, extremely important that you start with creating your conceptual enterprise data warehouse model.
Okay, thank you. And the next question is not so much related to, I think, to this session, but the next question is, when will R13 be released within the buy-in model?
Soon, very, very, very soon, which means actually I'm doing at the moment, I'm doing a final quality control. So it must be there the first week of February, I think. So next week,
Okay.
Beginning next week. But I'm doing the final quality controls.
Nice. Then we still got a question. Thank you for answering the question, and then thank you also, Patrick, for this elaboration, conceptual modeling versus logical modeling. I'm sure everybody will start applying it very Nicholas. And well, let's see what the next session will hold. Thank you for your time. Thank you for listening, everyone, and see you next time.
So, see you. Bye-bye.
Bye.
We at the Van Haren Group believe that organizations can benefit from shared knowledge and experiences, and we try to help them to do so. We are an independent, worldwide recognized content provider in management best practices and standards, well known for its flexibility and years of experience. Our education partners offer specialized training using our books, courseware, e-learnings, and exams. These partners play a crucial role in delivering high-quality education to professionals, leveraging our products to ensure comprehensive and effective learning experiences. At Van Haren Group, we're more than just a publisher. Our unwavering commitment to quality, passion, trust, fairness, and forward-thinking drives everything we do. We are dedicated to empowering professionals and organizations worldwide to achieve their goals and thrive in today's dynamic landscape. Dream, learn, and achieve with Van Haren Group.
Do you want to apply a best practice yourself and maybe leverage our services? Do get in contact with us. We are more than happy to advise how to take the next step.